Now we have two tasks. First on the blink, that is control an LED using Arduino. So first come to the circuit. So we want to control an LED. So first of all we need to connect it in a digital pin because we just want it to either off or on. So either high value or low value, we need this two state. That's why we have connected to pin number 13. Okay, so with pin number 13 we have connected an LED and a resistance with it, then a ground. So this circuit is quite similar to the previous one that I mentioned in previous video. Anyway, so in the code that I previously didn't explain, so let's come here. So in any Arduino code, we generally call the Arduino code as Arduino use case in terms of Arduino terminology. So in any Arduino use case, there should be minimum two function. One is void setup and another is void loop. There could be many more function depending on your work. For example, you can write many user defined function, but minimum it should have these two function. One is void setup, another is void loop. So what does this void setup do? Within this void setup function, you generally write that lines of code which will be executed once when Arduino powers on. So for example, you just give this Arduino a reset, so it is powering on, then this void setup portion will be executed, and after powering on it will continuously executing this void loop. So void loop will be continuously executing, and void setup will be executed only once. Now in the void setup, so void setup, within this block we generally write which pin we are using as which mode. So let's say we are using pin number 13 as output pin, right? That's why pin mode, which is a function, pin mode, then first syntax is pin number. So we are using 13, pin mode 13 as output. So we are giving an output that the direction is like this. So Arduino will give some output in this direction. That's why this is output. If it was this direction, it will be input. Anyway, so we are using just one pin, which is 13. That's why the pin mode 13 output. Now let's clear this. Okay. So now in the void loop, so as the name suggests, void loop, that means loop, so it will be executed continuously. So within this block, first of all, what I need to do, I am turning on the LED. So the code will be digital write. Why digital? Since we are working with digital pins now and we are giving a digital signal, either it is logical 1 or logical 0. So digital write 13, that is the pin number, and we are giving a high signal. So digital write 13 high, that means we just turn on this LED, and right after that we have a delay 1000. That means we are delaying this operation for 1000 millisecond. Okay, the syntax is in millisecond. So whatever you write in the within the delay block, it will be in millisecond. So you are waiting for 1000 millisecond. So you just turn on the LED, and you turned on for 1000 millisecond. So for 1000 millisecond, it is turned on. So when 1000 millisecond has passed, you have written digital write 13 low. That means you just turn off this LED again. So initially it was 1. So let's say this is LED, it is on for 1000 millisecond, then it goes off again. And for how many times? It is 1000 millisecond again. So again it is off for 1000 millisecond, and since it is a void loop, that means it will start executing again from the beginning here. So again it will turn on for 1000 millisecond, and again it will turn off for 1000 milliseconds. So this process will be continuing as long as Arduino has power supply. Okay, so this process is continuous, and this pin mode will executed only once when Arduino starts. So void loop will start executing continuously. So this is our basic program, and in your home I think you should uh, develop this circuit, and also you may change the values in delay. For example, you may write in fast delay as, let's say here 50, and here let's say 2000. Then you will observe what are the effects. Through this you can understand what are the effects of this delay and how can you find your desired response. So this is our task one. Our next task, which is the analog input. So here you are going to control the frequency of LED blinking. So just like our previous task, here we want to connect an LED with pin number 13. Let's say this could be any other pin, pin 12, 11, 10, 8, any digital pin. So if you write, let's say 2 here, connect 2 here, then obviously you need to define it here pin mode to output. So you may change it in your homework. Anyway, so this portion is similar, and what we are going to do, integrate this portion. Since we are going to control the frequency using uh, a potentiometer, that's why we need to connect a potentiometer, and this is a potentiometer that is the variable resistance. One end is connected to plus 5 volt and another end is connected to ground, and this signal, that is the knob that we generally move, is connected to A0. So through this A0 we will read what is the value is here, and then according to this value we will change the frequency of the LED. So let's come to the code now. So in the code, first of all, we defined a variable sensor value, integer variable, as 0. So this value is actually I just initialized a variable, and in this variable I will read the data from this A0 analog pin. So next, the void setup. Since we are working now 2 pin, one is pin mode as 13 output, just like our previous experiment, and another is A0 pin, and we are using A0 as input. That's why pin mode A0 input, and this line is optional, pin mode A0 input, since the default option is input. So if you don't write pin mode A0 input, then obviously that will not create any problem, but it is a good practice to write, since when it is written you generally understand what are the pins you are using, what are their configuration, whether it is output or input, and so on. So it is a good practice to write. Next, on the void loop. So first of all, what we want to do, we want to read the values of the potentiometer, read the voltage. Since we are supplying a voltage here, so obviously some drop will be in the potentiometer, and we are reading that voltage drop actually. So now this analog read. So analog read is a function who is basically a read analog value, and the syntax is analog read then the pin number. So we are working with A0 pin, that's why analog read A0, and then this portion is similar to our previous task, since we have just turned on the LED and we have delayed it for sensor value time. So if the sensor value is high, then obviously the delay will be higher. So when the delay will be higher, that means LED will be turned on for a longer period of time, and also it will be turned off for a longer period of time. So in the delay block we just provide the sensor value, so it will be dependent on this potentiometer setting. So in the simulation we will observe we may change this setting to 0 or 100 or any values, and using these values we generally control frequency of this LED connected to 13. So this is our task 2, and you should sense different values within this program, and you may observe the effect. It is recommended, since by sensing these values and other things, you may learn this concept at a greater depth. Now the homework. So in the homework, I am asking you to take two LED. One is red LED, let's say this one, and another is green LED, this one. And also you want to perform this same blinking task, but the condition is when red is on, green is off, and vice versa. So let's say initially red is on and green is off for a time defined by sensor value, right? Since I written here with an interval set by potentiometer. So similar to task 2, you will take input, analog input from a potentiometer, and you will give delay as defined by the potentiometer. So after this delay, green will be on and red will be off. Okay, then after same types of delay, red will again turn on and then green will turn off. So this is your task. And if I want to give you some hints, so the circuit configuration will almost like to this task 2, this one, but you want to integrate another LED. So you will connect any LED in any digital pin just like this one, and since you have inserted another, you are using another pin, so in the void setup you need to define this pin, and also within this void loop you need to write necessary code so that both LED will blinks. So I think I have covered all of the topics in this lab sheet. Now it's time to perform this task in Proteus. I will show you, don't worry, so stay with me.